In last lecture, we have already completed exercise number 1.1, 1.2 and 1.3 for chapter number 1, that is Euclid algorithms. So let me start exercise number 1.4. Here only two questions are there and both the questions are on the basis of the last concept of our chapter number 1, and that is how to find out terminating decimal number or check whether the following rational number are terminating decimal or non-terminating decimal numbers. So let me start example number 1 of exercise number 1.4. The question is, without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. Here two things are very important: terminating decimal expansion, and second one is non-terminating repeating decimal expansion. Here 10 examples are there in this exercise. Let me start first example. One rational number to given to you, you have to check whether it is terminating decimal expansion or non-terminating repeating decimal expansion. So first one is 13 upon 3125. So here you have to factorize numerator as well as denominator. Here numerator is 13, so you can't factorize it because it is a prime number. Now the denominator is 3125, so we can write 3125 is equal to 5 into 5 into 5 into 5 into 5. So 5 5s are 25, 5s are 125, 5s are 625 and 625s are 3125. So in place of 3125 we can write 5 raised to 5. Now according to our formula, if denominator is in the form of 2 raised to m and 5 raised to n, for m and n are real number, then we can say that the given rational number is terminating decimal expansion. Otherwise, it is not terminating decimal expansion, means it is non-terminating repeating decimal expansion. Now here denominator is 5 raised to 5. So we can write here denominator is in the form of 2 raised to n and 5 raised to m, where n is equal to 0 because only 5 raised to 5 is there. So you can write 5 raised to 5 multiplied by 1. So in place 1 you can write 2 raised to 0. So n raised to 0 and m raised to 5. So we can say the denominator is in the form of 2 raised to n, 5 raised to n, and that's why it is in the form of terminating decimal expansion. So decimal expansion of 13 upon 3125 is terminating decimal expansion. There is no need to find decimal expansion. Just you have to check whether it is terminating decimal expansion or not. So the decimal expansion of 13 upon 3125 is a terminating decimal expansion. Well, so let me start another example, example number 2. The example is 17 by 8. You know 17 is a prime number, so you can't divide into another part. 8, you can divide it into a prime factor. So 8 is equal to 2 into 2 into 2. 2 2s are 4, 2s are 8. So the rational expression becomes 17 upon 2 raised to 3. So if you observe denominator, the q means denominator is equal to 2 raised to 3 and is in the form of 2 raised to m and 5 raised to n, where m is equal to 3 and n is equal to 0, because only 2 raised to 3 is there. So you can write 2 raised to 3 into 1. So in place of 1 you can write 5 raised to 0. So here m is equal to 3 and n is equal to 0. So denominator is in the form of 2 raised to m, 5 raised to n, and that's why 17 by 8 is also a terminating decimal expansion. Now let me start third example. Third one is 64 upon 455. Now here you have to check whether the denominator is in the form of 2 raised to m and 5 raised to n. So let me divide 455 by 3 factorization. You can find out the factor of 445. So 455, when you divide 450 by 5, 5 9s are 41, 5 1s are 5. So 5 into 91. So if you divide this 91 by 7, you get 30. So 455 can be written as 5 into 7 into 13. You know, here P and Q are co-primes numbers. So you can divide 64, but you can divide 64 into 2 only, and there is no common in numerator as well as denominator. So 64 and 455, they are co-primes number. If you observe the denominator, here the denominator is 455 and its factorization is 5, 7, 13. So it is in the form of 5, 7 and 13. Not only in the form of 2 and 5, and that's why it is not in the form of 2 raised to m and 5 raised to n. Along with 5 there is 7 as well as 13, and that's why 64 upon 455 is not terminating decimal expansion. So the first example is terminating decimal expansion. Second also terminating decimal expansion because denominator is in the form of 2 and 5. Third one is not in the terminating decimal expansion because the denominator is not in the form of 2 and 5. Well, friends, let me start example number 4. The fourth one is 15 upon 1600. So 15, you can divide 15 into 2 parts, 5 into 3. While you can divide 1600 into divide by 5. If you divide by 5, you get 5 3s are 15, 1 and 0, 5 2s are 10 and 0. So 320 into 5. So 15 and 1600 are not co-prime. So first of all you have to convert into co-prime number, and that's why you can cancel this. So 15 upon 1600 is converted into 3 by 320. 3 and 320 are co-prime. So here you have to find out decimal expansion of 3 upon 320, not 15 upon 1600, because 15 upon 1600 is not a co-prime. But 3 upon 320, that is 3 and 320 are co-primes. Well, so 320, divide 320, so 2 into 160, so 2 into 80, 2 into 40, 2 into 20, 2 into 10 and 2 into 5. So here 1, 2, 3, 4, 5, 6. So 320 can be converted into 2 raised to 6 and 5 raised to 1. So if you observe the denominator is in the form of 2 and 5. Denominator is in the form of 2 raised to m and 5 raised to n, where m is equal to 6 and n is equal to 1. So 15 upon 1600 is a terminating decimal expansion. So friends, in this example, just you have to check the denominator, and for this you have to factorize the denominator, and you have to check whether it is in the form of 2 or 5. If it is in the form of 2 or 5, then it is decimal expansion. Otherwise, it is not a decimal expansion. It is non-terminating, repeating decimal expansion. Well, let me start example number 5. The fifth one is 29 upon 343. You know 29 is a prime number, so you can't divide 29 into other part. 343, you know it is a 7 cube. 7 7 ja 49, 49 7 ja 343. So 29 upon 7, 7 raised to 3. So if you observe the denominator, it is 7 raised to 3. So denominator is not in the form of 2 raised to m and 5 raised to n. That's why 29 by 343 is not terminating decimal expansion. Well, let me start example number 6. The sixth one is 23 upon 2 raised to 3 and 5 raised to 2. Well, you know denominator is already in expand form. So by observing the denominator, here denominator is in the form of 2 raised to m and 5 raised to n, where m is equal to 3, n is equal to 2, and that's why we can say it is a terminating decimal expansion. Well, let me start example number 7. The seventh one is 129 upon 2 raised to 7, 5 raised to 7 and 7 raised to 5. You know here also denominator is already in the expand form. But here it is 2, 5, but along with 2 and 5, 7 is also there. So friends, here by observing the denominator is not in the form of 2 raised to m and 5 raised to n. Along with 2 and 5, there is 7, and that's why it is not terminating decimal expansion. Now let me start example number 8. Eighth one is 6 by 15. So if you divide 6 and 15, they are not co-prime because there is common 3 in 6 as well as in 15. So 6 means 3 into 2. 15 means 3 into 5. You can cancel this 3. So you can get 2 by 5. So 6 by 15 is not a co-prime number, but 2 by 15, 2 and 5 are a co-prime number. So here you have to check whether it is in the form of 2 and 5 or not. So 2 upon 5. If you observe the denominator, it is in the form of 2 raised to m and 5 raised to n, m raised to 0, n raised to 1, and that's why 6 by 15. You can say 2 by 5 is in the form of terminating decimal expansion. Now, example number 9. 35 by 50. Again, 35 and 50, they are not co-prime. There is some common number in 35 and 50. So 35 you can divide into 5 7 ja. 50 means 5 2 ja 10, 10 5 ja 50. You can cancel 5, you get 7 upon 10. So 7 and 10, they are co-prime number. So if you observe the denominator is in the form of 2 raised to m and 5 raised to n, where m is equal to 1 and n is equal to 1, and that's why 7 by 10, or you can say 35 by 50 is in the form of terminating decimal expansion. Well, the last example, 77 upon 210. You know again 77 and 210 are not decimal, are not co-prime number. So 7 means 7 11s are. 210 means 7 30s are, 2 15s are, and 3 5s are 50. So if you cancel this 7, here numerator is 11, the denominator is in the form of 2, 3 and 5. So along with 2 and 5 there is 3, and that's why if you observe the denominator, it is not in the form of 2 raised to m and 5 raised to n. So it is not terminating decimal expansion. So friends, we have completed 10 examples of exercise number 4.1. Example number 1, it is on the basis of last two concepts of our chapter. That is, if a decimal number p and q, where p and q are prime number, if q is in the form of 2 raised to m and 5 raised to n, then it is terminating decimal expansion. Otherwise, it is not a terminating decimal expansion, or you can say it is non-terminating repeating decimal examples. And we have already solved 10 examples.